Hello there, we're going to talk about 4-6 arithmetic sequences. This is the second to last section that we're going to talk about in chapter 4. We're also going to get to geometric sequences next. But for today, it's arithmetic sequences, and you can see here we have 4 vocab words. The first one is sequence, and that just is a list of numbers that forms a pattern. Second one is term, and that's each number in a sequence. And then an arithmetic sequence is a sequence in which terms differ by the same number. Okay, so they go up or down by the same number every single time. And that number we call the common difference, which you'll see referred to by a lowercase d. And that's the difference between one term and the next in an arithmetic sequence. So the first thing we'll be doing today is just looking at sequences and determining whether or not they are arithmetic, and if they are, we'll find the common difference and then the next 3 terms. So the first thing that we do when we have a sequence is we're going to look at what's the difference between each term. And you see here 9 to 13, that goes up 4, and then 13 to 17, that's also up 4, and then 17 to 21 is also plus 4. So the difference is plus 4. And then once we know what the difference is, and we, like I said, we refer to that with a lowercase d, so the difference is 4. It says use that difference to find the next 3 terms. So the next 3 terms would be 25, 29, and 33. And that's all I do on that. And this is how I would show my work. I would write the sequence out. I would show here how I go from one term to the next. I'd write down what my common difference was, and then my next 3 terms. Let's look at one more like that. Same directions here. So if I, again, 10 to 8, that's going to be minus 2. 8 to 5 is going to be minus 3. And 5 to 1 is minus 4. So you can see here that it doesn't go down by the same number every time. So on these we would just write that it's not arithmetic. Okay? Now, this works just fine when we're just finding the next 3 terms. But what happens when we give you a sequence and we say something like find the 180th term? Now, we could get there eventually, but it would take us a while, and because of that, we as mathematicians like to do, try to use math to create a shortcut for finding terms and sequences. In the next part here, I'm just going to kind of walk you through how we got to that rule. So the first thing you need to know is just some terminology for math. So the variable a is often used to represent terms in a sequence. And what we do is we give this variable a subscripts. So the variable a sub 9, that's how you read that there, is the 9th term in a sequence. So if we're labeling terms of a sequence, we write a sub whatever term it is, and for the nth term, meaning any term in the sequence, we would write a sub n. So let's look here at this sequence 3, 5, 7, 9. 3 is the first term, 5 is the second term, 7 is the third term, 9 is the 4th term, dot dot dot, it would go on. So I would then label 3 a sub 1, 5 a sub 2, 7 a sub 3, 9 a sub 4, and so on. So the sequence we just talked about starts with 3, that's a sub 1. The common difference is 2. And what we're going to do is try to find a way to write a rule that we could find any term in the sequence. And that's what this table kind of walks us through. So the first term of that sequence was 3. We call that a sub 1. Now the second term, if you'll remember, was 5. And to get there, you do 3 plus 2, because the common difference was 2. So this 1 here is how many common differences we're going to use. So 3 plus 2 is 5, so that would, if we write it algebraically, first term plus 1 common difference. Now the third term was 7. To get there, we had to add 4 from the first term. So the first term, a sub 1, plus 2 of the common difference. So 2 times 2 there would get us 4, which would get us to 7. Okay, fourth term, again, to get, it's 9. To get there, we had to take the first term plus 6, which would have been 3 of the common difference. Alright, now hopefully you're seeing a pattern already. Let's look at dot dot dot. Okay, now look here. What I want you to look at is I'm going for the fourth term. I need 3 common differences. So if we're looking for the nth term, it would be my first term plus n minus 1. Okay, so we were looking for the fourth term, we needed 3 common differences. So any term that we're looking for, we're going to need 1 less common difference in that. That's where you get n minus 1 times d. So based on that pattern, we come up with a rule for finding any term in the sequence. So the pattern in the table shows that to find the nth term, you add the first term and the product of n minus 1 times the common difference. It's kind of confusing, I know, on how we got there. The most important thing is that you're going to need to know this formula here for arithmetic sequences. So put that in a big box, star it something. We need to be able to memorize this formula so that any term in the arithmetic sequence we can find. So here's what a problem may look like in your homework. Find the indicated term of the arithmetic sequence. Find the 16th term of this sequence, 4, 8, 12, 16. So the very first thing you have to do is figure out what the common difference is. And if we look at this sequence here, you can see that it goes up 4 every time. So my common difference is going to be 4. Now, I also need, if I look up here at my equation, I need to know what a sub 1 is. And a sub 1 is my first term, which is 4. I also need to know what n is. Well, n is the term I'm trying to find, and it tells me here in the problem I'm trying to find the 16th term. So d is 4, a sub 1 is 4, n is 16. So then all I'm going to do is plug those values into my formula. So a sub n, so that would be a sub 16, meaning the 16th term of the sequence, is the first term, which is 4, plus 16 minus 1 times the common difference, which is 4. So that would give me a sub 16 equals 4 plus 15 times 4. Now one very, very common mistake here is that people want to do 4 plus 15 and then times that by 4. That's against the order of operation rule, so please, please don't do that. So I have to do 4 plus 15 times 4. 15 times 4 is 60. So then the 16th term of my sequence would be 64. Okay? They'll also give them to you written like this, where instead of giving you the sequence, they will just tell you the values of each of the variables in your formula. So this says find the 25th term, which means n is 25. The first term is negative 5. The common difference is negative 2. So I'm going to plug that in to my formula. So a sub 25 equals a sub 1, which is negative 5, plus 25 minus 1 times my common difference, which is negative 2. So that would give me negative 5 plus 24 times negative 2 Now again, I can't do negative 5 plus 24 first. That's wrong. I have to do 24 times negative 2, which is negative 48. And then I add those two together. So the 25th term in that sequence is negative 53. And then finally today, we have to look at story problems that represent arithmetic sequences. So we have a bag of cat food weighs 18 pounds. Each day the cats are fed 0.5 pounds of food. How much does the bag of cat food weigh after 30 days? So first of all, we have to determine, is this arithmetic? It is, because it's going down by 0.5 pounds every day. So it's going down by the same amount every day. So once it's arithmetic, I have to determine what is D, what is A sub 1, and what is N. Well, D is 0.5, and it's going to be negative 0.5 because it's decreasing. Now the first term in the sequence is going to be 18 pounds, because that's where we start out with. Then it says, how much will it weigh after 30 days? So we want to know what's the 30th term in my sequence. And then I'm going to just plug that in once again to my formula. So A sub 30 is equal to 18 plus 30 minus 1 times negative 0.5. So A sub 30 equals 18 plus 29 times negative 0.5. So A sub 30 is 18 plus, and this is going to be negative 14.5, I believe. So that means the 30th term in this sequence is 3.5. So after 30 days, there's going to be 3.5 pounds of cat food left for the cats to eat. Let's look at one more here. Each time a truck stops, it drops off 250 pounds. It started with 2,000 pounds. How much does the load weigh after the 5th stop? Well, it does appear to be arithmetic because it's going down by 250 every time, so my difference would be negative 250. We start with 2,000 pounds, so that's going to be A sub 1, and then D, we want to know the 5th term in the sequence. Or not D, sorry, N. So then we have A sub 5 equals A sub 1 plus N minus 1 times D. So A sub 5 equals 2,000 plus 4 times negative 250. So A sub 5 would be 2,000 plus, let's see, 4 times negative 250 is negative 1,000. So A sub 5 would be 1,000. So after the 5th stop, they'd have 1,000 pounds left in the truck. Okay? So that's arithmetic sequences. As I said, we'll get into geometric sequences tomorrow, and we'll see you then.